Today we're going to take our quiz. Hopefully you already took your quiz. Then I want you to check your homework, which I'll put in Google Classroom, and then do these notes for 4.3 and start your homework. Your homework, I believe, is pages 9 and 10, and hopefully Mrs. Yem will have that up there so you know what pages to do. But I'll get back with you on that. So notes on 4.3. Let's get started. So today, we're starting what we call the shortcuts. We're going to start showing how you can prove two triangles are congruent without knowing about all 6 parts that they have. Now, we all know that triangles have 6 parts, 3 angles and 3 sides. But there's what we call the shortcuts that have been proven theorems that tell us, hey, you don't have to know about all 6 parts if you remember these shortcuts. The one we're going to learn today is called SSS, and it stands for side, side, side. And this shortcut says, if you have 3 sides of one triangle congruent to 3 sides of a second triangle, then they're congruent. So let's look at the example here. The first triangle I see 1 slash here, 1 slash here. 2 slashes here goes with this side, 2 slashes. And this side shows 3 slashes. And likewise, over on the other triangle, I see 3 slashes. So every side has a coordinating side on the other triangle that's the same length. And this is called side, side, side. You can abbreviate it by SSS theorem. So we're going to decide whether the congruent statement is true. Let's look at our first example here in A. I've got one side that matches one side of the other triangle. I've got XY that goes with WZ, and guess what? WY is a side for both of the triangles. So yes, WY counts because it's congruent to itself. So this one definitely shows us side, side, side. Okay, let's look at B. This triangle QPT, is it congruent to triangle RST? Well, if I look at it, I have 1, 2, 3, and on the other triangle, 1 slash, 2 slashes, 3 slashes. So yes, it is congruent by side, side, side. Now let's look at the third one. I see I have a 7 here, a 7 here. They share a side, but look at the third side. From A to B, it should be the same length as C to D, and it's not. So we do not have 3 sides. We just have 2 sides congruent to 2 sides. So this one is a no. 2 sides just won't cut it. We don't have enough information, and no, they're not going to be congruent. Okay, let's look at this proof right here. And we're going to try to prove right here that triangle ABC is congruent to triangle CDA. So first of all, I want to state my given facts. AB is congruent to CD. Okay, that's this one right here. I can say BC is congruent to AD. Both of these are given to us right there in the given statement, so my reason is given. I hardly have to think about that one because that was handed to me. Okay, so the triangles are already marked. AB is congruent to CD. BC is congruent to AD. The last thing I'm going to say to make these two triangles congruent is AC, which is a side of both triangles, is congruent to AC. And how do I know it? That's right, everything is congruent to itself by the reflexive property. Now I do have 3 sides congruent to 3 corresponding sides of the other triangle, and so now I can say triangle ABC is congruent to triangle CDA. And how do I know it? Oh, I've got 3 sides, so that's side, 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 and that's called the side, side, side congruence theorem. Notice what I was trying to prove will show up on my last line. Okay, let's try another proof here. We're given bunch of information here, so I'm going to start out saying what I'm given, because I have to get that into the proof. AE is congruent to CE. I'm given AB is congruent to CD. Okay, I see that my triangles are already marked. AE, CD. And then they tell us E is midpoint. Of BD. Okay, all of these are given right here in the given information. This is what we started our argument with, the given information. If E is the midpoint of this line, that divides it in half, so I know BE and DE are congruent. So I need to state that BE is congruent to DE, and that's because I know what midpoint means. So I'm going to say the definition of midpoint. That's how I know those two segments must be congruent. Oh, do we have two triangles congruent? 1, 2, 3, 1, 2, 3. Yes, I can say triangle EAB is congruent to triangle ECD. And how do we know it? That's right, side, 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 congruence theorem. Notice we don't know anything about the angles. We just have to know about the three sides. Okay, let's do a little practice here. We're going to state if the two triangles are congruent. If they are, we'll state how we know. So let's see. They do share this side, but I don't know anything about this other side. So this one I'm going to have to say no. They're not going to be congruent, and I certainly don't have enough information. On number 2, I do know vertical angles are congruent. I do have that angle congruent to that angle and this one congruent to that one. But I'm looking for sides, so I'm going to have to say no. This is all about the angles, and I want to look for sides. On number 3, I'm looking 1, 2, 3, 1, 2, 3, and this one is a definite yes. And how do we know it? By side, side, side congruence theorem. 3 sides of one triangle congruent to 3 sides of another triangle. Let's look at number 4. I see a 1, a 2, a 1, a 2. Hey, they share a side, so that's their third side. So we can say yes, they are congruent by side, side, side congruence theorem. Okay, number 5. I see 2 and 3, 2 and 3. So the side they share, I'm going to label or diagram here with a 1 slash. So 1, 2, 3, 1, 2, 3. We're going to say yes. The two triangles are congruent by side, side, side congruence theorem. Don't need to know about the angles. Okay, now we're going to state what additional information is required or needed in order to know that the triangles are congruent. So for side, 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 I already know QS is congruent to QS. What I need to know is that QR is congruent to QF. And if I knew that those two lines were congruent, we'd be all set. In number 7, I know HF is congruent to HF, but what I need to know is HG must be congruent to HC. Okay, and if they were congruent, I'd be able to prove the two triangles are congruent. Okay, number 8, I've got 1 here, 1 slash there, 2 slashes, 2 slashes. What I need is the third side. So what I need to see is that QS is congruent to IK. And then on the next one, I've got 1 and 1, 2 and 2. What I need is AC to be congruent to DF, the third sides. And if I only had that information, I'd be able to prove them congruent. Now we're on number 10, and let's see, we know they share IK, so that's automatic, but what I need to know is that IG would be congruent to JK. And on number 11, GI is congruent to GI, so we already know that. What I don't know is about WI and HI. So I need WI to be congruent to HI in order to prove them congruent by SSS. Okay, time to work on your homework, everyone.